سجل محاضرة. بسم الله الرحمن الرحيم. زملائي الكرام، السلام عليكم ورحمة الله وبركاته، وأهلا وسهلا بكم بلقاء جديد في سلسلتنا الهندسية انجينير توك باللقاء 73، والذي يتحدث عن صناعة البريكاست والكونكشن بالبريكاست. ما هي مساوئ العقد ومحاسنها ومقارنتها مع العقد التقليدي أو الوصلات التقليدية. محاضرنا اليوم المهندس محمد فليس، وخريج جامعة حلب، ماجستير بإدارة المشاريع من جامعة حلب أيضا، وهو يعمل حاليا خبير تصميم البريكاست كونكشن أو العقد بالكونكشن، وهو أيضا مدير تطوير الأعمال بشركة بيكو التي تقدم حلول إنشائية تساهم في حل المشاكل الإنشائية في المشاريع، وأيضا يعمل بمجال الفاليو انجينيرينج من خلال تقديم هذه الحلول. Dear colleague, welcome in our new webinars from our series Engineerstalk. Our lecture today about precast industrial. What is the benefit? What is the disadvantage and advantage of this precast and precast connection? Our speaker today, Mr. Mohammed Flayes, is civil engineer graduated from Aleppo University. He had master civil engineering in management from Aleppo University. He is design expert, precast connection, and development manager in Biko Gulf. Mr. Mohammed, I inshallah hope the benefit and the value information will be presented today from you. I will leave you with our engineers and this, inshallah, a new webinar.
Okay. Thank you very much, Mr. Abdul Hakim, for this introduction, and thank you, my friend, my colleague. I hope I will add some information in this lecture. Yeah, I will speak today about precast and what the advantage of the precast, then some case study or some project done by precast, and how I will connect the precast elements. This is the agenda of today speak. As I said, I will speak in introduction on precast, because all of us, we heard about precast, but I'm going to show some photo inside the factory, from the site, from stockyard, from all the process of this precast. Then I will speak about the challenge in the precast industry. Yeah, I will speak in English. Mr. Abdul Hakim. Yeah.
Yes, Mr. Muhammad, it's clear.
Yeah. Yeah, here and for all of us, we know this cast in situ, and we are familiar with this cast in situ concrete. But the precast, it will be similar, use the same material, it's the same concrete, but here it will be different handling. In cast in situ, we are preparing shutter, formwork, scaffolding in the site. Then we cast the concrete, and we will do the structure. In precast, same material, we will use the same reinforced concrete, but a different handling. We will do the concrete in the factory, then we will stock it and curing in the factory. Then we will deliver it to the site and erect it to get the structure. This is the process of the precast element. First, we will do this producing and casting in mold. We will prepare mold in the factory where there is controlled environment, and there is shade, and there is light, there is everything. We can work 24 hours because everything, it will be controlled inside the factory, and not like site, we limited to the site condition and weather, many conditions. Then after we cast the concrete inside the mold, we will make the curing. You know, this concrete after casting, we need to take care about concrete to avoid the crack and avoid this problem of concrete. Inside the factory, we will have some chamber. We will have some method to take care for the concrete to to reach the strength, required strength without any problem. After we finalize this precast element, casting and curing, we can get it and transport it to site. And then we can erect it in the final place to get the structure. All this, we can see it here in site photo, in site factory. This is some photo from one precast factory. This precast factory, it will be shaded by shade. Then here we can, we will see this table. We'll make it this table for casting of a precast element. And this table, it can be tilted, it can be rotated to for some issue to remove the precast element. Here we have this precast factory. We'll have many tables. Sure, we will have many methods to cast the precast. Here, one method, it will be on the table. There is another method to cast on the bed. We will see some photo for that, but it will be the more or most famous way to use this table and to prepare the mold on a table and make the concrete. Here, see this table will have the formwork. This formwork, it can be normal width or wooden, or it could be steel. It will be as per the required, but it will be more famous to use this steel mold. Then we will have this some area to prepare the reinforcement. As we said, this same material of reinforced concrete required reinforcement. This area here prepare the reinforcement. As I said, here there is light and there is a shade. We can work 24-hour, no any obstacle for that. Here, as I said, also we have this some chamber to take care for curing of the concrete. After we cut the concrete on the table, we can take the table inside this chamber, and we can implement the required curing for the concrete to reach the required strength and to accelerate to reach that strength. After we cast and we take a curing about this precast element, we can handle it to make it in the stock. There is lifting. We can use the precast element to locate it in the stock yard. What I speak about a precast element, we have many type of the precast element. What we said, that element is a precast element to use for wall. We have another type of the precast element for hollow core. This hollow core needed for the roof. It's a normal precast, but there is core inside the element here to minimize the weight. And normally this element, it will be a pre-stress. Yani there is a bed, we will make this strand, we will pull the strand. Then there is machine to cast the concrete. And the type of this concrete for this hollow core, no need any shutter, because it's named like zero slump. No need any, the machine is run, and behind it, it will be create the hollow core. And this normally is too much famous, the hollow core, and too cheap and required in the market. This hollow core, it's too much needed in the site, and it can go for more span because it's a pre-stress element, and it's light because of this core. And above of this hollow core, it will be on the site when we erect the, because this is used for the roof. When we erect it in the site, required some secrete above the hollow core. For this reason here, there is some rough surface above the hollow core. Also, there is another type of element of a precast for the bridge, this girder. Also, this pre-stressed element required another type of the bed. They will pull the strand and they will cast as per the shape. It will be T or I section as per the design. In the conclusion, here I will come back here. As we said, the precast is like normal concrete, but different way to handle this. I'm repeating because some people enter recently. Yeah. Here we will have this for precast. Inside the factory, we'll have table to make the mold and to cast. We will do the mold above the table, and we will prepare the reinforcement inside the factory, which allow us to make the work 24-hour, 3 shift or 2 shift. Then after we cut the concrete, we can get the table with the concrete to the curing, where we make a curing to take care about the concrete to reach the strength in fast way. After we make the curing and we reach the required strength, we can get this element to stockyard. As I said, there is different type of precast element. That's what we speak about this for wall. We have another type of precast element. It's named hollow core. This hollow core, there is a core to minimize the weight of the element. And this use zero slump concrete, no need mold. And there is a strand for this. There is another type of precast element. It's named this girders to use in the bridge or a big span. Normally this like this, what we see here, more than 30 meter. 30 meter, it can design I section or T section or whatever required for design. It's as per the mold and design. And this pre-stressed element sure. The advantage of the precast, we can start the superstructure of the building along with the substructure. Then in the site, they will start excavation and prepare the foundation. In the same time, we can do the superstructure to cast the column, beam, wall, or etc. For this reason, we need in the precast big stockyard to put the element to be ready when the foundation ready to take this element. Here in the precast required a strong planner engineer to manage, because if there is mistake in a planning, that means no use for a precast, because we are using the precast to get the building in fast. If I will get mistake in the planning, I will finish the foundation and that column not casted, we cast some other element, then it will be a problem. For this reason, required a strong planning engineer and strong stockyard to cast all the element. When the site ready, we can take the required element to the site. Here now, after we cast the element and we see it's required in the stockyard, we handle this and we take it through a trailer to the site. Here it will be delivered to the site. Then it will erect the element. This here we erect the hollow core. Now we see here in this building we are using only hollow core as a precast. The other element cast in situ. It's normal. Yani, always we are trying to get the maximum optimum solution. Sometimes we are going for partial cast in situ. Other part it will be precast. Other part steel. It will be as well the study and optimum solution. Also here another project, but here we are using full precast. The column, wall, even the roof. All this precast erected in precast. See if we can give you idea about this first or this project. This project in Dubai, it was 2,100 villa. The agreement for precaster to produce or to erect 6 villa per day. Imagine you finish 6 villa per day. This here unit, it's 2 villa actually. Required per day, finish 6 villa. Yani imagine if we'll go for 36 villa, one day he will finish all wall for this 36 villa. Next day he will finish all hollow core. Then within 6 days must be finished this 36 villa. Then if we divide it, that means per day you finish 6 villas. This is the advantage of the precast. We can finish the structure very, very soon. And sure, there is another advantage for precast. You will get a high level of quality. No need a plaster. You will come for paint direct. Then here we can conclude this precast advantage. Sure, it will be expedite the construction. As I said, this in this sample, the villa here. This never ever it can be reached by cast in situ 6 villa per day. This it will be yani this required for a precast. Even you will pay more because sometimes for a precast it will be more expensive than cast in situ, but they will go because it will save time, and time is money. If you calculate this with that, you will see this better than the cast in situ. Sure, to be a precast benefit solution or to be economical solution, you need reputation. You cannot come for one building or one villa or a small structure to say this I need to do it in a precast, because this it will be cost me the same process. What I will do it for this number of villas, I will do it if I have only one villa. I will prepare mold. I will do all this study design. I will do everything same for one villa. For this reason, it will be overhead more for one villa. For this reason, precast for less number of typical, it will be not benefit, required repetition. Then this first advantage for the precast, I will expedite the construction. We can get the construction very soon. And as I said, this is quality, because this all precast element, it will done by inside the factory where there is a control environment. We can get very high quality, and precast, it will be cast on the table where there is a smooth face, no need any plaster. This smooth, it will be give me excellent lower surface and no need any plaster. It will be ready direct to get the bend. On the side, no need this shutter and scaffolding and formwork. It will be sure all this, it will be eliminated. If you will see this here photo, you will see less number of people. Only you will see crane and you will see some trailer to come to deliver the material. Then I will have this in the side. I will have less stock material. I will have less less opportunity, less operation in the side. Here, if I will go to compare between the cast in situ and precast, see, as I said, it will be clean side because no formwork, no waste material. It will be ready from the factory only to erect. You will see very clean side. Sure, for cast in situ, all the activity will be done on the sides. For this reason, it will have many waste material. Also for the precast, because it will be reinforced concrete, you will not find any crack. For cast in situ, unfortunately, because this is small element block work, some differential in the foundation, it will be create crack. As we said also, here no formwork for the precast. For the cast in situ required many formwork, many shutter, which is required more time. Here now I'm going to show some project done by a precast to give idea about the precast, because now precast, as mentioned from Engineer Abdul Hakim at the beginning, it's now become a famous industry. All people, they are thinking about the precast. Yes, now I will go to see, show some project done by precast. Here one car park in Ras Al Khaimah. This car park, actually, sometimes, as I said, it will be in a precast to have typical element to use the precast. Sometimes the typical, it will be inside the building itself. And suppose now I have this element, I will see this element repeated many times inside the building. Then this building, it will be useful for the precast. Yeah, not mean I need to have many buildings from this building to go for a precast. No, I need typical element. Here in car park, if I will look for this column, maybe I'll see this column 100 times. Then it will be nice. I will go for a mold and I will prepare it and I will do it in a precast. Then for the school, it will be also same, because there is typicality, there is classroom, it will be repeated, and this element, it will be, there is repetition. For then this school, it will be also useful to be for a precast. And sure, for the school, there is here a specific requirement. You know, a school delays the school to let the client lost. He needs the school to open before opening the school. If he will delay the contractor or construct the school, if he delay it, that means he will lose 1 year for invest the school. For this reason, most of them, they use this precast to accelerate and to start invest the school. Also here, one industry for oil and gas, where there is pipe racks. These pipe racks in oil and gas, it will be column and beam, and there is a pipe of oil, it will run above of this beam. Before, it was not famous to go for precast. But now most of this pipe rack become for precast. And I will go more details later in this meeting about these pipe racks. See here, all this column and beam typical, it can be designed one time and one mold, then you can repeat the casting and you can get the structure very soon. Even these manholes, even the big manhole, if I will go for this cast this manhole in the side, require big excavation, require many this, it can be run. As I said again, this required to be to have typical element. Suppose this manhole, I have 30 manholes of this. I will prepare the mold one time, then I will cast it to get it to site. This here, one big project in Oman for manholes. Imagine this, it was more than 6 meters, the height. Also for a foundation, imagine this foundation, normally for foundation, preferred to be cast in situ because it's heavy element, and to handle this element, it will need more money and cost. But sometimes for far area like this in island in Abu Dhabi, there is one for oil and gas, an island, not able to reach the cast in situ and not able to get people to work there. For this reason, they get it in a precast. They get it here in a precast factory, and they get it ready to erect it on the final stage. But in normal practice, foundation is preferred always to be in cast in situ due of cost. Because this heavy element, imagine this 3 meter, 4 meter, it will be many ton. To handle this, it will be so cost, but required. Another type of project, this accommodation, where we have this staff or labor accommodation. Also, so there is typicality of many typical elements inside the building. Or sometimes it will be typical, repeat the same building. We have this staff accommodation repeated 8 times or 5 times or whatever. This it would be a very good solution for a precast. And like this, where I have a more typicality, sometimes this precast, it will be reach same cost of the cast in situ. As I said, because the mold, it will be prepared one time, then it will be. For the villas, here for villas, yeah, I believe now all when we have this bulk villa, they will think only for precast. Because as mentioned, this project, what I highlight before, 6 villa per day required to be ready per day, 6 villa. Imagine this magic number, you cannot reach it only. Also for this infrastructure or road, this here where we have bridge, sure this it will be here above the water, how I can work. If I will go for cast in situ, it will be too costly and it will be maybe impossible. For this reason, precast it will be the good solution or the best solution. Especially there is here a big span, it will be reach 40 meters, 40, and easy to cast it. In this case, like this project, sometimes you can move the precast factory to near the site. Like if you have typical element, you can do the mold and you will get the crane and you will get the skilled people near the site to avoid this transportation. Because if you have a heavy element or a big number of elements, it's better to cast it near the site and erect it direct to avoid this transportation cost. But sometimes it will be no, even this logistic far, you need to do it in a factory and transport it to the site, case by case. And it will be studied carefully because here money, when there is money, it will be studied very carefully. Now here's the challenge of a precast. Until now we see this precast, it will be very good industry, but there is a challenge for this precast because we are going to cast the element separately, column, beam, wall, and to get it to the site. But now how I will assembly it in the site? I need to connect the wall. I want to connect the column to foundation. I want to connect beam to column. I want to connect column to column. All this, there is 2 ways to connect it. One way, now if I will go for column to foundation, how I will connect this column to foundation? I will speak about conventional system. Then I will move for the mechanical connection. I have 2 ways to connect the column to foundation. Sure, there is other, but now this famous, what people they are thinking is they will connect the column to foundation. They will go for this system or this system. Now let me go for a conventional system. I have precast element. I want to connect to the foundation. Foundation, that means I need to make the foundation in a way to take the column. This its name bucket. I will do bucket like this here in concrete. And then I will insert the column. This here, no any mechanical connection. It will be like a normal reinforcement. I need only to take care about embedment of this column inside the bucket. There is some requirement in the code. You need, if I have this D, I need to go 1.5 D. Yeah, that means if I have this 1 meter here dimension, I will go 1.5 meter for the bucket in order to get fixation of the column. Here in this way, I will prepare this conventional. I'm speaking about the conventional system. I will go to prepare this foundation by cast in situ here. Then I will bring this precast element to insert it inside the bucket. I will do some probing to handle this, to get it aligned to vertical in the same place. Then I will do some, I will do here some grouting to make one unit between the column and bucket. Here I'm also drawing some, I draw here some column. This here it will be the cast in situ foundation with the bucket. Here I will have this probing. I will have here also additional element. It's named counterweight to get this stable until to get the final strength. With this, which will be required maybe 3-4 days until to get final strength of the grouting. Here's some site photo how I can how I see this column, how I have this probing. And they will fix this probing with the precast element. They will connect it with this counterweight. And this crane, and here it will be, there is the grouting. This here, the bucket should require more reinforcement because this to be designed to carry this column to the bending moment created from the cantilever of the column required more reinforcement. Then I have also more this formwork for this bucket because I need to cast inside and outside. There is here 2 formwork to get this shape. I will get it this. Sure, this not easy to get it, but it's difficult to get this here. And also to get the fixation between the column and this bucket, I need to do some rough surface inside the column. This is a precast element. We need to do some here rough surface, like I highlight here, in order to make the embedment and to get the vertical or to take this fixation. Here's some site photo. And here there is also one challenge. I need to keep the crane until to fix all this probing. This it will cost me more to wait and to grout and to make this probing. And this probing also, it will cost me to make obstacle in the site. When I will do this probing, I will have less chance or less freedom to move inside the factory, inside the site. Here now I will speak about this another way where it is mechanical connection. And this mechanical connection, I can connect the precast element column with the foundation cast in situ by easy way. No need this bucket. I will make only dowels from this foundation, cast in situ foundation. I will get these dowels here. I will insert it during the casting, and I will do some steel element inside the precast here. What we name it here, column shoe. This it will be produced by Pico, this bolted connection here. I will insert this in a precast element. I will provide here 1 dowels. Then it will become to erect direct. No need this bucket and no need this temporary support. No need anything. It will be erected like you are erecting steel structure. You will get this element. You will put it above dowels. You will put this nut and done. And even this easy to make this leveling and make this alignment because this not final fixed. And here the advantage of this mechanical connection, as I said, it will be quick and easy to erect. No need this headache for crane to stay to, and I have this propping and I have this grouting. All these things is not required in this connection. Also, this no need the temporary support, as I said, and less time of crane, because soon when you make the nut finish, the crane can move for the next column. And no need this cast in situ between the bucket and the precast column. And this shallow foundation, as I said here, when I will go for this bucket, I need here, I make more dips to provide the fixation between the column and foundation. I need to go for 1.5 of diameter of this column. For this reason, I need to go for more dips of foundation. Maybe here for this bolted connection, no need, because I need only to catch the anchor bolt. Here the foundation, it can be near the, sure, this it will be as per the soil report and as per all the study. But in all cases, if I will compare it with the normal one, here I can use shallow foundation. Then easy for design, because this design, we have free tools on website, this Pico. It can be gives the forces coming from the column. We can know what the shoes required. For the now it come to the mind where I will use these dowels. I will have challenge to erect the column, precast column with this dowel. This sure it will be a headache, and but we solve it. We will provide this template during the cast in situ to maintain the dowel in the same place. And in precast yard also there is template. Then the whole, it will be a front or the same place of this anchor bolt. Then no issue. We have a lot of projects and done, alhamdulillah, no any issues. This simple and need careful to use only this template. Here I will now show one small video to show this bolted connection. Unfortunately, the voice, it will be not clear. I will speak about this video because it will be not. So here showing how this column connected with the one. Here easy to align, and here is the column main floor. As I said, we have these tools easy and to define. We have this free software available on the website. Yeah, even this pivot we can take it. Now in precast yard, how we make this template? How we make it this template? Now this show, and here's the side how it. Now this 3 floors column. We have only 2 guys to erect with the erector. So somewhere. This is the column 2. And the side the template with the custom feature. Very easy to move it. We are speaking about connect the column with the foundation. Same concept, it will be for beam with column or other. As I said, no temporary breaking required. And now vertical element, no any breaking. The site is free. Crane operator and 2 guys. Yeah. All this information can be getted from website. Yeah. Now here I will come a little bit about technical to see. As I said, this rigid, it can be for column to beam, here column to beam, or column to foundation, like what we see in the photo and the video. and even column to column. Sometimes I need column for many levels. I can connect column to other column. Yeah. Now here for some technical issues here. For a failure of tension, it will be many way to take this filler. It will be cut from here, or it will be pulled from full from concrete, or it will be many cases. This it will consider an hour. I will not bother you. This it will be shared this presentation. You can read it. But with this way of this filler of the element, it will be cut or pull or cut the concrete. All these things has been considered in our software where we design this connection. Also for the connection, we have two stage to design. First stage where we have this erect and we make the nut here. Still, we don't have a grout. This here we name it erection stage. This erection stage, we will implement the self-weight of column and some wind load for the element. And all the load here, the force, it will be go through to the foundation through the anchor bolt. This here we name it erection stage. Where we have final stage, sure, this it will be not remain as it is. Here the precast, after we erect this, we have a grout. Then you will not see this hole. After we make the nut, we make a grout, you will not see this hole. For this reason, we name it final stage. After make a grouting, after we close this recess, we will have this final stage. This final stage now it will be implemented like reinforced concrete structure. That means it will now all the load it will be transferred through the concrete and reinforcement. And the load it will be implement the final load from dead and live and wind or whatever there is lateral load. This here the final stage, and this here I'm giving a concept, but all this case we need the force, or you need the force. You can apply in the software. You can get the number of shoe required for this, and there is some required some additional reinforcement around this shoe to transfer the load. This connection, what we said, it tested not only theoretical design. We have many tests for this, even this under seismic. We have many places. We did the seismic in Italy, Spain, and Italy and China. We this indeed many tests done for this application. And this behavior of this connection has been shown after study, same cast in situ, not far from the cast in situ. Here also we will see also the seismic action. If I will go to compare all the connection type between the column and the foundation, I will get all the possible way to connect. Suppose now here we make it 5 tests. Here we did 1 test, and we see the stiffener of this pico. It will be this in red one. It will be similar of the cast in situ. We did this test. This here pico connection. The other it will be here bucket, and here the other one bucket with rough surface, and here the dowel. All this we make it this test. And we find this pico connection behavior, it will be not far from the cast in situ. Now here real photo from this connection. This here before the casting, and here's the precast element. Here's the template which we provided to precast yard, and here's the shoe. And this recess, it will be removed to allow later to make this nut inside the anchor bolt. This, the green one. Here, the erection, as I said, after do the erection here, make the nut, we will make the grouting to close this recess. Now here, use this connection for circular economy. And now there is, if you want to erect one building and later you need to remove it, you need to construct one building for a temporary. Like what here we face it in Dubai Expo, there is some building has been erected and later they want to remove it. This, it will be nice to use this also connection. Name it circular economy. Here's the connection. like photo to connect a column with foundation. This we name it column shoe. And here we'll have this from cast in situ anchor bolt. Also for the wall, we will have another type, but same. This here, it will be inserted inside the precast. Also, we name it wall connection. Here we name it column connection. Let us come for reference where we can be used this connection. Here in precast car park, where we have this column, see this column for 4 floors. You can bring it ready from precast yard to the site, and you will have here this connection to connect it with the foundation. This it will make the actually this the project was designed with bucket, but they faced some issues and they converted to get this mechanical connection. Do of this fast, you know, this always required to investor. He want to finish his project soon to start invest. Here they find this mechanical connection better based on this visibility study. Here another car park also use also this here the foundation, and here's the precast. Here see how it will be erect. Also this required to connect here substation building to connect element, and it was here in substation some requirement for blast proof. This connection has been designed to get this blast proof. Here some one project in Sharjah in UAE. It was challenged also as Al Quram Visitor Center. It was in a precast. Sure, without this mechanical connection, I believe it will be not easy to do it. See all this here. We used our wall shoe and Cobra to connect all this element. Even there is the roof. There is here some connection. Also here in, as I said, this in Dubai Expo, here's some precast element. They want to do it and temporary, and then later they want to remove it. This here mechanical connection, it was a unique solution for it. Here, even this connection, it will be not only for foundation, it will be required also for many levels. Divide it and take it. Here, see some site photo for this during the precast. All this here connection with wall connection. Here another car park, also a connection with mechanical connection, no bucket. Here see heavy. Also in cladding, when we have this cladding, precast cladding, we need to connect this precast element. We can divide the precast element and we can connect it with mechanical connection here. You cannot see it, but this connects the precast element each other by this mechanical connection. Same way, it will be one way, it will be shoe, and the other it will be dowel, and nut and bolt and finish this. All this here, this towers in Abu Dhabi. Also here a dome. Without also a mechanical connection, I believe it will not possible to do it in precast. Divided this dome in segment, and then we link it each other by this mechanical connection. We have dowel and we have here nut finish. Here's some site photo. Also for factories where we have very heavy load, sometimes to minimize the cost, we can make these dowels to get the shear and to take the here shoe to take the moment, to minimize number of the shoes. We will keep here because this here this dowels for the shear, and here we have this dowels for the shoes to carry the and see here very heavy column with cantilever with a crane, everything. Here another project, it was a column 26-meter height. This also without mechanical connection, I believe it will be not possible. Divided here this column, this now running project in Abu Dhabi. Divided the column and connect each other by this mechanical connection. Here. You will not find it because after this make the mechanical connection will make route, then nothing it will be here. This, which I will come for more speak about this pipe racks, because this here big challenge. As we know in the structure, we are avoiding this, or we are observing the lateral load by shear wall and frame action. Here in pipe rack, we have only the frame because we don't have any wall. All load is coming, lateral load coming for the frame. Here we did this one project in Oman by this Bico mechanical connection here. And all it was heavy force because there is some pipe and some dynamic load. It was very heavy, heavy forces, which it will be cost more. For this reason, we moved the connection a little bit far to minimize the force value in order to minimize the cost of the connection. Here. Here, actually, it was this in 2017. This at the same time they have the client. He has three pipe racks. He in hurry to get this project. He tried to get one of the three. He decided to get one of them precast and to keep the other two in cast in situ. And this it was first time in Oman to go for a precast for this type of structure. This structure, when we did in the precast, actually it was challenging to client and consultant to get decision to approve it. Even we spent 3 months to get approval for this project. But after 3 months, and that time another two pipe racks, it's running, the two cast in situ, they start in the beginning. But this third one, when the client decide to go for a precast, is still facing challenge for approval. Even that time, we went to head office in Netherlands to get approval from this client or consultant. Sorry, was in Netherlands. We to face him face to face to get approval. And the end, after 3 months, we get approval. Then they decide and they start for a precast. The third one was they decide for a precast, finish before the other two. After that, this Orbic, the Authority of Oil and Gas in Oman, they decide to go for precast for all project. In 2019, there is big pipe rack in Duqm. They go directly for precast. They not think to go cast in situ or not. They decided for a precast. Now, whatever there is pipe rack there, it will be for precast because they find the quality and the fast and everything. They find it. And sure, here, as I said, we also to match the cost with the cast in situ because the same budget what put it for cast in situ, they want it for precast. We make some idea for structure, and alhamdulillah done, and we get same cost. This here some photo for pipe racks for connection.
Mr. Ali, please, can you go back to the previous slide? I don't know, just I want to see because I noticed some not organized this element.
Yeah.
Sorry for this term because
yeah.
this connection here.
Yeah.
And the column and the base with the connection and the column. I found something here. I don't know if our colleague they noticed this or it is belong to other connection behind this column.
No. Actually, here's the connection between the beam, main beam, and the column. Main beam and the column. Here we are speaking about this column and beam because the same concept.
Clear. I confused with the other column. Sorry.
No. I'm going where I'm speaking about connection between the beam and column and beam, main beam and secondary beam. And here it was a very heavy lateral load because many pipe. And here actually this project in 2017 in Sohar, it was in Oman. It was 10-meter precast and another 10, there is another 10 to be a steel structure. It was total height 20 meter. And here it was challenged to get the steel structure erected here. There is double in the top. And alhamdulillah done perfectly and no any issue have been. Here's some detail for how we make this shoe and dowel. Here's the shoe from one side and dowel from other side. And here we make the then this some side photo. It's so simple. As I said, as client convinced this Orbeck, now all this pipe rack in Oman, it will be another one in 2019 become direct. And even this not divided. Before in Sohar in 2017, they make it 10 meter, what it means, precast. As I said here, 10 meter, another 10 meter steel. In 2019, when they get another pipe rack, they make it the 20 meter full precast. No more. Yeah, they convince for this method. They make it full height, full, this very heavy and very heavy pipe racks project. This is what I can explain about this connection. Thank you very much. If you have question, please let me know.
Thank you, Mohammed.
Thank you.
Thank you. حقيقة محاضرة كانت جميلة.
تسلم.
الله يبارك فيك. زملائنا برفع الأيدي لنعطي الأسئلة بالترتيب. أستاذ عمار لطيف يتفضل. أستاذ عمار تفضل. أستاذ عمار لطيفي. طيب أستاذ أحمد أبو فرع. عمار تفضل عمار.
أنا فكرت نكتب كتابي أو بفتح المايك.
خلاص تفضل شو سؤالك؟
إذا بدنا نعمل كانتليفر بالبيم بنوصله بكونكشن مع الكولمون، فينا بالهاي الكونكشن اللي كان عم يحكي عنها الزميل؟
يعني مثلا عندك هوني كولوم وبدك تطلع منه cantilever, you need to make cantilever direct from the precast. Yeah, sure. The issue is force. يعني when I calculate the moment and the shear or whatever, I can design it to select the required shoe. But if it will be heavy, maybe sometime it will be not fit. يعني maybe I need more shoe. It will be studied case by case. If there is heavy load and heavy big cantilever, it will be studied, but it's possible. فهمني استاذ عمار؟ شكرا.
استاذ احمد تفضل يا استاذ احمد.
السلام عليكم.
وعليكم السلام
ورحمه الله وبركاته.
يعطيك العافيه مهندس ابو علي، يعطيكم العافيه.
الله يسلمك، حياك الله استاذ احمد.
الله يعطيك العافيه، منور ما شاء الله عنك والله. الله يعطيك العافيه.
انظارك حلوه يا استاذ.
الله يحييك ما شاء الله عنك. Excuse me, I will ask about the precast sandwich panels.
Yeah.
If there is any solution from Biko to connect sandwich panel with another sandwich panel.
Yes, exactly. We have here, actually, I can share some other here. We have this column shoe, and we have also something is named wall shoe. Here, this wall shoe.
Yes.
Here, this wall shoe, it's the same concept here. It inserts inside the panel, and it can connect. It can connect the panel to panel. It's so simple. Same concept. I will make here dowel from first panel, like I'm doing here, dowel from precast. Then from the other panel, I will get this shoe, what is named here in Biko, we name it Somo. Yeah.
Yes, the same concept with the solid panels.
Same concept, yes. But here it will be less and cheaper because it will be less force. Yeah.
Yes. Okay, clear. Thank you. Thank you very much.
شكرا استاذ احمد. زملائنا برفع الايدي بعد اذنكم اي سؤال. بدي اسال لبين ما زملائنا يرفعوا ايديهم ويسالوا.
اسئلتك صعبه يا استاذي، انت اسئلتك صعبه.
لا والله بس لبين ما نشجع زملائنا. الله يبارك فيك. بالنسبه باول البرزنتيشن قدمت صور البريكاست كانت لهولوكور سلاب.
نعم.
بالبريكاست او بالهولوكور عم نصب مثلا سبان 120 متر ومنقطع الهولوكور، كيف بدنا نحافظ على الديفليكشن؟
Yeah. Okay. Yeah, this is good question actually. Yeah. Here, see, when they will cast this bed, normally it will be more than 100 meter length. In this factory, it was 150. Yeah. They will pull this. They will stress the strand, then they will cast it, and they will after getting some strength, they will release the strand, and they will make some before cutting. They will make some counterweight. There is some, yeah, it will be not only cut, it will be sure, then camber, it will be collapsed. There is some counterweight that will be used for before cutting this hollow core. Yeah. But I don't have photo here to show.
هذا هي الحقيقة، هذا اللي صار سؤال لدي، يعني 120 متر أو أكثر، فكيف بدنا نحافظ على الديفليكشن بكل قطعة من قطع الهولو كور؟ تمام. الدكتور وسام، هذه تفضل دكتور.
السلام عليكم استاذ عبد الحكيم.
الله يبارك فيك. وعليك السلام.
شكرا جزيلا للسيد المحاضر على المحاضره
حياك الله استاذ وسام، حياك الله.
حياكم الله، شكرا جزيلا.
على فكره الدكتور وسام من الدكاتره الشغالين بالجيوتكنيك، وعنده مجموعه الحقيقه رائعه على الانستغرام
ما شاء الله.
شكرا جزيلا. شكرا جزيلا استاذ عبد الحكيم. معذرة بدي سؤال فيما يخص lateral stability regarding wind effect or earthquake effect. في حال انه انا عندي كان warehouse or جملون، في شلون راح اقدر اربط البريكاست كولوم عن طريق بريسنج or شو الطريقة الميكانيكية for lateral stability؟
Yeah, okay, for this seismic, now before starting this, because I came late for this lecture, some seismic happened here in Ras Al Khaimah. For this reason, I become late, yes. Yeah, this seismic here, it will be, if I will go for this photo where there is force. Yani, me to design this shoe, I need the forces. I will make analysis for this lateral load, whatever it will be, come from wind or dynamic load or seismic or whatever. Then I will utilize it. Normally, I'm getting this force ready from the ABC contractor. Now, like this, what I'm saying, this bibrax, the ABC contractor, he will put all this load and he will give me the force near where I need to make the connection. Simply, I have this software. I will put this MNT, all directions. Then I will get how I need, how many this. Now, for when I will get this rigid, then I have frame action. Then no need any pressing. When I will have this frame, it's rigid. Then it can get this stability for the lateral load. But here there is another question, because when we are doing this frame action, we will do it in one. I will come for the bibrack here. I will come for this main beam. This main beam here we have this rigid, and we'll have this frame, and this lateral load it can be absorbed by a frame action. But for the other direction, here they will keep it pin connection. But each 2 or 3, they will make it rigid. Sometimes they will not do it rigid, they will make some pressing. This there is 2 choices. If they want to use steel, they can avoid this to make it rigid. By this way, it makes the space frame or 3D frame to absorb the lateral load.
Thank you for explanation. Thank you very much.
Thank you, Ustaz.
شكرا دكتور.
شكرا جزيلا. شكرا جزيلا.
طيب نشوف في يمكن بالشات في عنا، خلينا نشوف إذا في أسئلة. أقول لك Mr. John, what is the price difference in general if choosing mechanical connection phase dowels or other traditional connection in element?
Yeah, we did actually this exercise for here. What I prepared this presentation here, it was based on visibility study for one big project in Qatar this year. What we prepared, they compare if they will go for this bucket and normal connection, or they will go for this mechanical connection of Beko. We make all this study. I can share you, Mr. Abdul Hakim. You can also share it to others, but I don't have it in figure. But if you calculate all this crane, grouting, all these things, because we specify it in element, we get this price, and we compare it with Beko. Then we find Beko is cheaper and faster. We get it complete here and complete there, and we find it it's better. I can share this to distribute it for this colleague, inshallah. I will share with you, Mr. Hakim.
Yes, so we will share it with the friends. مستر عمار سأل سؤال ثاني، بيقول لك شو السوفت وير بتستخدموه للكونكشن؟
Yeah, we have this free tools in website. I will share with you also this link. It can be only give it the force, and
Good.
you need to only register with Biko to share. I will
Okay.
share this link. Now I will share this, what I'm sharing, I'm writing to give it to you.
اي
then
والله
we will
بليز.
distribute to our colleague.
شكرا سيدي شكرا.
Mm.
السؤال بيخليك الأستاذ معتز. For a precast cladding system, non-bearing panels supported laterally on steel structure are there, and special requirement to consider in the design for both serviceability and strengths.
Yeah.
شو السؤال ما عرفت أنا حقيقة.
Yeah, actually this, and I understand this question. Yeah, simple. Yeah, this in a cladding normally it will be less force. See here, you will not see this connection as it's so small. We have this wall SOMO, what we name it SOMO. It's simple to put it inside the precast, and it will be nut and bolt and finish. It's so simple. It will be the same concept. We get the force, we implement, we see how size of this SOMO, and we'll do it. Simple SOMO.
تمام. طيب بدي أسأل سؤال يلا لبين ما شو اسمه. ايش الفرق بين البولت كونكشن او الدولز كونكشن مع البوكيت كونكشن؟ ليش بنستخدم هي وليش بنستخدم هي؟
Yes. No, actually, before to get this specialist to make this mechanical connection, it's the unique solution to make this bucket. Yani how you will connect. Yani you need to connect precast element with this with foundation. What you will do? You will not find. Yani this I believe the available way to do it. But if you have this mechanical connection, then you for this reason.
This is like socket shoe يعني.
Yeah.
What is the difference in design?
Yeah, here in design it will be make this requirement of the code. As I said, you'll make deep 1.5 meter from this diameter of this column. Then you will consider as fixed. You need to apply the requirement of the code with the grouting, with the depths, with everything. Then it will be considered as rigid, and you need to pay for this. You need to design this wall, because as I said, this wall, it will be work, this small wall, it will work as cantilever. You need more reinforcement to carry this. You will assume some rotation or some load for designing it. This is the design.
As a structure, we will consider the connection here hinged or fixed.
No, it will be fixed, because you will go for 1.5 meter. Yani sometimes you are going 1.5 meter deep. It's heavy, yani more like a person is inside this pocket.
Actually, why I asked this question, because I think since back 10, 11 years, there is one designer, precast company, they consider this connection as hinged.
Just
it came to my mind that I prepared this question.
Yeah, and this like lapping. When you have this lapping, you will consider continuous. You need to require apply the load code the requirement to consider one piece. It's the same here. We are going, but this requirement of the code coming from test, not coming only for this. And there is one requirement to make this rough surface here, as I show in one photo. We need to do this rough surface for the column to provide this. Yeah.
Okay. زملائنا إذا في أي سؤال. حقيقة أبو علي أنا بشكرك كثير للمحاضرة.
بارك الله فيك.
بشكر حقيقة كمان بيكو اللي دائما بيقدموا لنا محاضرات والتكنولوجيا والحلول الإنشائية، وإن شاء الله بنلقاكم بلقاء آخر.
بارك الله فيكم. شكرا جزيلا. شكرا أصدقائي.
شكرا.
All
our colleagues, thank you very much for this.
Thank you.
Attending our presentation, and we hope to see you again in coming webinars. Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum assalam wa rahmatullahi wa barakatuh. Assalamu alaikum.